Welcome to our Chi 24 talk. It's weird that it knows what I want, usability and interactions with Copilot for novice programmers. I'm James Prather, and I'm presenting on behalf of my co-authors, Brent Reeves, Paul Denny, Brett Becker, Juho Leinonen, Andrew Luxton-Reilly, Garrett Powell, James Finnie-Ansley, and Eddie Antonio Santos. For many decades, programmers have been instructed in learning to code by writing many small programs. However, with the rise of large language models and associated tools like ChatGPT, and in this study, GitHub Copilot, that has been turned on its head. And while there have been many evaluations of programmers using these tools, this study is actually the first to detail novice interactions with GitHub Copilot, as our study collected data in April of 2022, when GitHub Copilot was in its first week after its initial beta release. This is before the release of ChatGPT, some months later. So, what we present in this paper is how students interacted with GitHub Copilot when they had initially not been exposed to any sort of large language models or generative AI in the first place, which is going to be increasingly difficult to find as students are going to become more and more acquainted with these types of tools. So this provides not so much as a current standard, but rather the starting point from which we can look back on as we progress with these tools and with students' exposure to them. And in this study, we present two novel interaction patterns with GitHub Copilot, which we have termed shepherding and drifting, which we will discuss here momentarily. You can see here in the first figure the way Copilot works, which it suggests code here in gray text. And then if you hit tab, it accepts it and moves the cursor over, dropping it into your code file. And then here's the next suggestion. So it can be one line or multiple lines. Our research questions for this study were, how do novices interact with GitHub Copilot when they first encounter it? And how do novices perceive their first experience of using GitHub Copilot? And so there's been a lot of prior work on large language models now. They've been thoroughly explored in the last 2.5 years or so. It's been shown that they can generate code quite well. They can solve programming problems. They can explain programming error messages. They can generate hints. They can even solve other types of programming problems like Parsons problems. They can also generate content like for instructors. And so they have a lot of use and application in programming, and especially in introductory programming. But they haven't been studied nearly as much for novices, and especially how novices use them. And so that's what this study attempts to fill the gaps on. And so in this study, we looked at students aged 18 to 22 enrolled in an introductory programming course in the United States. The language of instruction was C++, and we recruited 19 students to participate in the study. And all of them were novice programmers, had very little experience to programming before this class. And we basically had them in a lab and asked them to solve a programming problem they had not seen before. In this case, it was modeled after the classic game Minesweeper. Here's the problem description. If you want to read that, you can pause the video. So This was about something that we would have tested them on about 2 weeks before, just to make sure that they had plenty of time to familiarize with the content. So we watched them solve this problem with GitHub Copilot, and then we wrote down everything they did and said, and then asked them a few questions directly afterwards. And here's our post-interview questions. Do you think Copilot helped you better understand how to solve this problem? If you had a tool like this and it was allowed by the instructor, do you think you'd use it for programming assignments? If so, how? What advantages do you see in a tool like Copilot? And what fears or worries do you have about a tool like Copilot? We directed these questions because we were still at the very beginning of large language models entering programming courses, and there was still not a lot of direction about where this would go. And so these are it was very focused on the tool itself and our user-centered approach for analyzing it. So we used reflexive thematic analysis to analyze all of the observations and comments that the students made. If you're interested in reading more about reflexive thematic analysis, you can download the paper and take a look. In our results, we found 4 major themes, and here they are: interactions, cognitive, purpose, and speculation. Each of these themes had many sub-themes inside of them, which you can see here. You can see the count of the times we tagged them and the number of unique participants who experienced these. And you can see this side is for observations and this side is for interviews. Interactions was by far the most, followed by cognitive, and then purpose and speculation. We also have them organized here by interview question, just to be able to see how they slotted into which particular interview question. Now, if you're interested in looking more at that, you can pause the video right here and take your time. We also organized them by participant. We could see the general spread of them over the population that we sampled. And you can see that by interview as well. So in our first theme, and probably most important theme, was interactions here. And we had these sub-themes: coding, which is kind of behavior with any sort of regular coding activities, typing out code, adapting auto-generated code, and deciphering Copilot suggestions. User experience, which is how Copilot appears to the user and any difficulties using it. And then accept and reject. And accept here is when a user presses tab and it drops the code right into their file. And reject is when a suggestion comes up from Copilot, but the user continues typing and effectively ignores it. So we have some novel interaction patterns here. And the first one here is shepherding. And it consists of several behaviors that we notice. The first one is what's called the slow accept, which is when a user types out a Copilot suggestion word for word. The second is backtracking, which is when the participant deletes code that they had just accepted without modifying it. And the third is adapting. This is when they accept the generated code and then try and adapt it to fit their needs. And so when they did these 3 patterns together, these 3 behaviors together, it formed this shepherding pattern, which is effectively when the user tries to coerce Copilot into generating the code that they think they need. And if you're interested in learning more about this pattern, then we encourage you to read the paper. The second interaction pattern is drifting, and that's based on 2 behaviors. The first one is trying to decipher prompts that they're given. Users spend a lot of time trying to read and understand the code. Oftentimes, it was code they could not understand. And the second one is adapting, when participants would try and adapt code that had been given to them, which they didn't understand. And so this pattern really is accepting code, trying to modify it, deleting it, and then doing it all over again, and sort of letting Copilot bounce them around between ideas without really ever focusing on a solution of their own. And if you're interested in finding more about that and the quotes from that, then we encourage you to read the paper. Um, there are also other themes here. Cognitive. Students were confused about the code that they were given. We think this has implication for either helping or harming metacognition in novice programmers. And of course, students had positive and negative sentiment about it too. Either they were excited or they were frustrated with the kinds of things that it would suggest. Um, Students also seem to think that like the reasons for using Copilot, and they would give it some kind of agency almost. They would think it was guiding them to something. They also thought it would speed them up, perhaps. And they also thought it would enhance their learning. And finally, the last theme here is speculation, which is just that many students voiced some ideas about what AI could or couldn't do in the future. Okay, so these are the interaction patterns that we found, and we discuss them in great detail in the paper, as you can see. And we also talk about user perceptions and the way they interacted with Copilot and how that changed their emotion and uh, perhaps impacts their metacognition and self-efficacy even. Um, and it's also very important to note that um, this paper tries to differentiate between expert usage and novice usage, which are very different and have different goals, and they're going to use the tools differently. And there are many more considerations to think about with novices, such as how large language models can have inherent biases, and we need to teach that, etc. The final contribution of the paper is design implications based on novice needs. So there should be, we suggest, some controls that would allow for a novice user interface, um, something about controlling the prompts, either being able to control how many lines are shown to the user, or being able to show or control when prompts are shown to users and in what context. And we think this might help with some of the interaction patterns, especially something like drifting that we noticed. We also think that these tools could have the potential to provide some metacognitive scaffolding to users, and that might involve some kind of unintrusive UI element directly above the user's code to or above the suggested code to help them cycle through different code suggestions and see and help that exploration component that has been noted in other literature. And um, finally, there should be a little more transparency with it. Right now, Copilot is really more of a black box. We think that should help users see into that black box, such as suggesting what it's using as input or saying what it's using as input, a confidence value of what it's showing you, and its own estimation of the skill level of the user. And this kind of information would be helpful to novices and give them more confidence in suggestions. So there's a lot of future work to be done, and many of it has been done since the study was conducted. And we think that one of the real values here of our work is that it provides this baseline of user experience for novices with large language models from which we can base future work upon. Thank you, and we hope that you enjoyed this presentation and that you will download the paper and engage more deeply with it. Please email us if you have any questions. Thank you.